In this video, I want to have a look at induction proofs that involve divisibility. So we're just going to run through one example, and that's asking us to prove by induction that 3 to the power of 2n minus 1 is divisible by 8 for all n greater than or equal to 1. So we're going to run through the standard sort of structure of an induction proof. So we're going to first start off by showing it's true. So show true for our lowest value. So that's going to be for n is equal to 1. So for us, that would be 3 to the power of 2 times 1 minus 1, which would just be 3 squared minus 1, which is 9 minus 1, which is just 8. And obviously 8 is divisible by 8, so then we can write therefore true for n equals 1. Then we're going to assume it's true for n equals k. So what that's going to look like is we're going to have 3 to the power of 2k minus 1. And we need to somehow write that that is going to be divisible by 8. So if a number is divisible by 8, we could write it as 8m, where m is some integer. So it doesn't matter what number that m is, as long as it's a whole number, because if we have something that is divisible by 8, that means we could divide it by 8 and we'll still get this whole number as our answer. So we're going to assume that this is true, and then we're going to prove that this statement is still divisible by 8 for n minus k. Sorry, for n equals k plus 1. So to prove that, we're going to write 3 to the power of 2k plus 1 minus 1. And we're going to simplify this down, and hopefully we can simplify it to something that is divisible by 8. So I'm going to expand that out, so I'll have 3 to the power of 2k plus 2 minus 1. Then I'm going to split this into 3 squared times 3 to the power of 2k minus 1. So that's because when we multiply things with the same base, we can add their powers. So I can split this one, so my 3 squared is here, and my 3 to the 2k is this bit here. Now that's going to be 9 for the 3 squared, and this 3 to the power of 2k, I'm going to use this here. So I'm going to rearrange this expression. I'm going to rearrange it. I'm going to add 1 to both sides. So I'm going to have 3 to the power of 2k is equal to 8m plus 1. So if we've assumed that that's true, then this equation also has to be true. So I'm going to replace this 3 to the power of 2k with an 8m plus 1. So 8m plus 1. And then I've got my minus 1. And I'm just going to write by assumption there as well, so that I know where that replacement has come from, that substitution. Now if I expand that out, I'm going to get 72m plus 9 minus 1, which would be 72m plus 8. And then 72 and 8 are both products of 8, multiples. So I can factorize 8 out, and I'd have 8 outside of 9m plus 1. And because it's got that 8 out the front, we know that m's an integer, so this is just going to be a whole number. And I've factorized out that 8, which means this is divisible by 8. So I can write is divisible by 8. And therefore, it's true by induction for all n greater than or equal to 1. Right, so that's an example of one proof that involves induction and divisibility.